Hi there. There's another video of me solving random code problem. So today we have the drum game. So let's begin. We are given an array of integer nums, right? And we are initially positioned at the first index, and we want to reach the last index, right? And each element in the array represent your maximum jump length at that position. So return true if you can reach the last index, false otherwise. So 2, 3, 1, 1, 4 here, right? So two mean you can jump one step or you can jump two step, right? Because the value represent the maximum number of jump, right? Maximum jump length here, from that position, right? Maximum jump length, right? Same for here. We can jump like this, right? Or we can just jump one shot to four. Okay, so there's a lot of combination to check, right? Um, so we can do this by simply starting at the last element. We can have our target equal to the last element, which is index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So this is our last index, right? And it takes 0 step to get to the last index, right? If we are already at the last index. Right, so we can just simply start from the second to last index here. Okay, so if um where we are at, right, which is 3 here, right? Uh, and if we are at 3, right, and the maximum we can jump is 1, right? So if the maximum we can jump is 1, then we will be able to get to our current target, right, which is 4. So the answer is yes, right? So if we are at 3, right, and we can jump one step, which means we can get to 4, right? Because 3 plus 1 is greater than or equal to 4, right? So the position where we are at, right, the index, right, plus the max jump, right, if it is greater than or equal to the target, right, which means which means we can reach, right, the target, right, from the current index, right, the current position, but also like the index. So if the position index, which is where we are at right now, right, plus the maximum jump that we can jump, and if that is equal to greater than or equal to the target, which means we can reach the target from this position, right? So 3 plus 1 is greater than or equal to target 4, right? So which means we can update our target here, right? Okay, if you think about it, if we can get to 4 from 3, right? Which means if we can get to 3, so we update our target here because if we can get to 3, then we know that we can get to 4, right? Because we already figured out whether or not we can get to 4. Yes, we can, right? If we are at 3, then we can get to 4, right? So our new target now is going to be 3. Because if we can get to 3 from anywhere, right? Then of course we know for sure that we can get to 4 from 3, right? Based on what we just found. So we keep going. Um, 1, right? We are at 2, right? The maximum jump we can jump is 1, right? So and that is equal to our target, right? So we can get to 3 from 2, right? So we can update our target again, right? So if we can get so if we can get to 2, right? We know for sure that we can get to 3, and we know for sure that 3 can get to 4, right? So we keep going. Here we are index 1, and the maximum we can jump is 4, right? Which is 5, right? 5 is greater than or equal to the target, which means we know that, okay, 1 can get to 2, right? If 1 can get to 2, 2 can get to 3, and 3 can get to 4, which means anything that get to so anything that can get to 1, right? Which means we can get to 4. right? Right. 3 can get to 4, right? And 2 can get to 3, right? And 1 can get to 2. So anything that can get to 1 can also get to 4, right? Okay. So the last one is 2 here. So we at index 0, we can plus 2, right? So 2 is greater than, and also we have to update our target, remember? So 2 is greater than 1, right? Well, we mean we can get to the target, so 0 can get to 1. So we return true, right? So if when we exit the while loop, the loop, right? If our target is 0, right? Which means we will be able to reach to the last elements there. Okay. So let's look at a different example here. Second example, we have 3, 2, 1, 0, and 4, right? Okay. So the target will be 4, right? 1, 0, 1, 2, 3, 4. So it takes 0 step to get to 4, right? So at 0 here, 3 here, right? 3 plus 0 is still 3, right? So it's smaller than the target. So we cannot get to 4. We cannot get to the destination, right? So our target is still 4, right? So 2, 2 is 1, right? 1 plus 2 plus 1 is 3, right? With still smaller than the target, right? So our target stay the same. Same for here, right? 2 plus 1 is 3. 3 plus 0 is still 3, right? So when we exit the while loop, the for loop, our target is not the first index, which means we cannot get to the last elements, right? Because we are starting from the first index, right? So our final target has to be 0. And in this case, it is not. So we just return false. Okay. So this is one pass. So this is ON. So we can have our target equal to nums of length, right, -1. We can start from the second to last element. Right. So if the position we are standing at, which is I, right, plus the maximum jump we can jump, if that is greater than or equal to the target, right, which means we can update our target equal to target, right, equal to nums of I, so it's equal to I, right? Okay, and we can return if the target is equal to 0. If the target is equal to 0, we can get to the last element. Otherwise, we cannot. All right, accept it, and it worked. Thank you for watching.